Yeah, hi everyone. I hope you are doing well. I just uploaded the scores for the exam and I have to say I'm really positively surprised. Most of you did really well. So where does it leave us for the class now? So in the previous lectures we covered really the basics of deep learning. Of course there's always more to talk about, but I think this gives you a good foundation. And yeah, remember this is just an introductory course, so we can't cover everything in a single course. But yeah, so in this lecture I want to wrap up with convolutional networks. There are some advanced concepts that are worth talking about. And then in the next lecture I want to talk about recurrent neural networks for text classification. So after the advanced concepts and the next lecture on the recurrent neural networks, I will then switch gears and talk about the generative models. So we will talk about autoencoders and generative adversarial networks and transformers. So with that, we have now this foundational deep learning stuff, and then we will have also some generative modeling with deep learning. Hope that will give you a good overview of the field overall. And what does it mean for this class? I mean, we won't have another exam, but yeah, that doesn't mean you don't have to pay attention anymore, because we will still have weekly quizzes. And there will also, of course, also be the class project. However, since we don't have an exam anymore, and we have kind of covered all the foundational skills, I think I will make the lectures, or at least try to make them a little bit shorter, so that you have maybe more time in the week. I will still aim for the 75 minutes, but rather below than above 75 minutes if possible. So this lecture might be maybe slightly, we will see how it goes, but I had originally like 80 slides and I think that was way too much, so I cut it down to approximately 40. But yeah, these topics I'm going to cover today I think are really important and essential if you want to use convolutional networks, so I can't make it that much shorter. However, I will focus on keeping it rather short so that you get the introduction. And maybe you can also, if you're interested in these topics, study some of the papers I'm linking. And there might be one day also a more advanced course where we can dive into these topics in more detail. But with that, let me get started. All right, let's get started by me giving you the overview of the topics I have in mind for today. So there are 8 topics overall I want to talk about. So first, I will start with the introduction to padding. So padding is a concept that allows us to add pixels to the input so that we can control the output size of the convolution operation. So when we have a convolutional layer, we can control the exact output size by using padding. Then we will extend familiar concepts like dropout and batch norm to the two-dimensional settings when we have convolutions. So we talk about this as spatial dropout and spatial batch norm. Then I will show you 2 common convolutional network architectures. So last week we talked about LeNet-5 and AlexNet, which are kind of ancient architectures already in the grand scheme of things. Today I want to talk about VGG16 and ResNet. So they are also already like 5-6 years old, but they are still very good in terms of the prediction accuracy on a variety of data sets. And I think these are nice architectures to show you that by making deep neural networks deeper, we can get slightly, actually substantially better performance, but at some point even making these models deeper doesn't help. So we have to use certain tricks, and one of these tricks is implemented in ResNet. Of course, there are many more architectures, but like I mentioned earlier, we can't discuss here everything in this lecture. So I have to be a little bit selective, and I think these are really good architectures to start with, because they are also still very competitive in terms of the prediction performance. So, and then 2, I would say, not so important, but very interesting topics. So I will talk about how we can replace max pooling with convolutional layers. So in that way, we can have a network that doesn't even have to have max pooling layers, in that way only having convolutional layers. But then at the end of each convolution network, as we have seen in the previous lecture, we always have these fully connected layers. So the question is, can we also get rid of these fully connected layers? Yes, we can. So that is the topic in this video, where we'll talk about replacing the fully connected layers by convolutional layers as well. So these are kind of like thought experiments to help us also understand or think about convolution in a slightly different way than before. And then, finally, the last topic is transfer learning. It's not very specific to convolutional networks. It's a general concept. It's the concept of training a network on a large data set and then fine-tuning it to a smaller target data set. So this is especially useful if you don't have a very large data set available. So in that way, you can train your model on a larger related data set to find, let's say, good weight configurations, and then you can use that pre-trained model to fine-tune it on the data set you care about. If you would fit your model on the target data set, you may not get good results if you don't pre-train. So in that way, we will also take a look at that, which can be particularly useful for your project, your class project. Why do we talk about it now? That is because that's something usually we often encounter in the context of deep neural networks, because there's the famous ImageNet dataset consisting of millions of images. So here I will show you a VGG16 network pre-trained on ImageNet that you can use and fine-tune for your target datasets if you are working on an image problem. Okay, so these are the topics, and in the next video I will start with padding.